Good morning, guys. So we're still continuing our unit. We're on 7.2 where we're talking about complementary and supplementary angles, and our essential question today is how can you classify two angles as complementary or supplementary? So, and again, that's a question. What this question is really asking you is how can you look at two lines and figure out if they're complementary or supplementary. That's what that's really trying to ask you there. So just trying to clarify what you're looking at. Real quick, I'd like to go ahead and just do our warm-up, and our warm-up here is asking us to identify three different angles, and we talked about this in our last video. So I'd like you to go ahead and pause this video for just a second and take a look and see if you can answer these on your own. And let's go ahead and look at number one. So as we can see, number one right here is labeled as 90 degrees, and then more importantly it has also the box right here to signify that it is 90 degrees. And sometimes when you guys are looking at these angles, you won't actually see the 90 degrees, you'll just see that box. So you need to associate that box with 90 degrees. Anyway, if you guessed that it was a right angle, then you were right. Good job. Okay, right here, number two, we have an angle that is 30 degrees. In terms of angles, anytime we have something that is less than 30 degrees, it is going to be an acute angle. And remember, anything that's less than 90 is small, and small things are acute, so it is an acute angle. The next thing that we have right here is going to be an angle that looks like it's 120. That is definitely greater than 90 degrees, and anything that is greater than 90 degrees but not 180 degrees is labeled as obtuse. So again, that is an obtuse angle. If you got that, good job. Alright, so I want to take a look at our words. We have 4 vocab words that we're going to actually cover today, and I want to make sure that you guys are very familiar with these. And again, you can look back at this video anytime when you need to. Alright. First one that we're going to look at is adjacent angle. Now, an adjacent angle, as you can see, are they are angles that share a side and a vertex, but they don't overlap. So just as a reminder, if I haven't talked about it already, these right here, these parts where the lines meet, these are called vertexes. So anytime you see vertex, that's what it's saying. It's like where the vertex meets are these points right here. Now they're saying that they don't overlap. Now the really important thing is that it says it shares a side. It shares a side. So for example, this right here is an adjacent angle because angle A and B, they share this one line right here. That makes it adjacent. This right here is not adjacent because even though there's angles A and B, there's a space here. Do you guys see this gap right here? There's a space. So because they don't share a line like this one, it's not considered adjacent. Now, let's go ahead and take a look here. We have another example of a not adjacent angle because we have A, which is overlapping on B. And remember right here in our definition it says that it doesn't overlap. So this is not an adjacent angle either because A is overlapping on B. A is asking what the total angle for all of this is, where B just wants to know what the angle for that is. Again, right here, we have another not adjacent. We have an angle that's going right here, and we have an angle that's going over here. But even though they kind of technically share a border, they have two different vertexes. So see that there's two vertexes? So they have a border, but two vertexes. And remember, they are sharing a side and a vertex, and they don't overlap. So that is our adjacent angle.